Okay, so this is my submission for the take-home/oral test for Engineering 111. The first problem I chose to do was the 75-point part of a circle problem. And the question asks, from the image above, find the perimeter and area of the shaded portion. The circumference of the circle is 17 pi inches, and the perimeter of the large rectangle is 46 inches. So I'll start over here. So I began by making a picture. So this is the circle, that's the large rectangle, and then it's split into 4 smaller rectangles of equal size. Here I show that this rectangle, the diagonal right here is equal to this diagonal, and this diagonal is the radius. I'll explain more about that later. And then I list what we need to find. So we need to find the area of the shaded portion, which is this part right here, and the perimeter of the shaded portion, which is that plus that plus that plus that. And so far we know that the circumference of this entire circle is 17 pi inches, and the perimeter of the large rectangle, which is the addition of all 4 of these smaller rectangles, is 46 inches. I then listed my variables down here, which we'll be using later in some equations that are coming up. So I listed that C is equal to the circumference of the circle, L is the length of the top right rectangle in the circle, and I'm just using this rectangle as the top right rectangle. W is the width of this rectangle, and then A subscript R is the area of the top right triangle, AC is the area of the circle, R is the radius of the circle, and P subscript R is the perimeter of the entire rectangle. Some assumptions I have are the corners of the large rectangle are touching the perimeter of the circle. This is so we can assume that the diagonal from the center to the opposite corner of the rectangle is equal to the radius, because if this corner was not touching the perimeter, it would not be equal to the radius. And then another assumption I'm making is that the crosshair in the circle, which is these 2 lines, splits the large rectangle into 4 equally sized smaller rectangles. So these are in fact rectangles, they are not another shape. And then my quick estimation is that the area of the shaded portion, which is this right here, will be less than 1/4 of the area of the circle. And this is because, well, this is 1/4, and since you're taking out a little bit right here, this shaded portion should be, in theory, less than 1/4 of the area of the circle. So here I start to list out the steps to start tackling this problem. So number 1, we know the perimeter of the large rectangle is 46 inches. That's all of this. So the outsides, so this means that the outsides of the smaller rectangle should add up to 1/4 of the perimeter of the large rectangle. So this is, just imagine this is the top right rectangle that we were talking about right here. This is this one. And here's the perimeter, so it's 46 in total. And this right here, this section, the width plus the length, should be 1/4 of the entire perimeter of the large rectangle. So I'm going to be going off of that for the rest of the problem. And then some equations I'll be using later is that 1/4 of the perimeter of the entire rectangle is equal to the length plus the width, which would mean 1/4 of the entire perimeter of the large rectangle minus the width of the top right rectangle is equal to the length of the top right rectangle. That's just using some algebra to switch around the variables. And then same here, 1/4 of the perimeter of the large rectangle minus the length of the small rectangle is equal to the width of the small rectangle. And then this we'll be using this later. The circumference of a circle is equal to 2 pi r. And then to find the area of the shaded portion, we'll be using this, which is 1/4 of the area of the circle minus 1/2 of the area of the small rectangle times, or no, not times, sorry, that's another bullet point. We'll just be using this later. I'll explain why this is later on. And then another equation we'll be using is pi r squared, or the area of a circle formula. And this is, I don't know if I said this is the circumference, this is area. So the second step, we need to find an expression for the length and width of a smaller rectangle, which is just one of these four, but we're mainly focusing on this one. And this we're going to be using the equation that I listed above here, which is 1/4 of the perimeter of the large rectangle is equal to the length of the small rectangle plus the width of the small rectangle. And then, as I mentioned above, the diagonal of the rectangle is equal to the radius of the circle, because the diagonal stretches from the circle's center right here to the edge up here, because this is the circle is making contact with the corner right here, so radius. And then knowing this, we have this. So here's the width of the top right rectangle. Here's the length of the top right rectangle, and then here's the radius. And since this is a rectangle, this would be a 90-degree angle, so we have this right triangle here, which here's the radius is the hypotenuse, the width and the length. So now we can use the Pythagorean theorem, where we get the radius squared is equal to the length squared plus the width squared of the small rectangle. And then now we need to substitute, so we know r, we'll figure that out in a little bit. So now we need to substitute an equation for the length or for the width. So we'll do that in a bit here. Number 5, we can solve for the radius using the circumference formula, which is 2 pi r. And we know that the circumference is 17 pi inches. So, did I list it down here? Just a second. Okay, I don't know if I listed the radius, but the radius would be 17 pi is equal to 2 pi r. Divide 17 pi by 2 pi. The pi's will cancel out. Divide 17 by 2, and you get 8.500 is equal to the radius. So now that we know the radius, we can use the following equation. R squared is equal to W, or the width of a smaller of the smaller rectangle squared, plus we can go up to here, and it usually would be length of the smaller rectangle squared, but we got up here that 1/4 of the perimeter of the large rectangle minus the width of a small rectangle is equal to the length of a small rectangle. So we can substitute this expression right here in for the length, and then square that. And then we need to do this because once we know either the width or length, we can use this equation right here, 1/4 times the perimeter of the large rectangle is equal to the width plus length to solve for the other dimension. So we need to solve for one of these, and then we'll be able to solve for the other one. Going on, the area that we are trying to find is equal to 1/4 the area of the circle minus 1/2 of the area of the rectangle, because so we have the entire circle, the shaded portion is within the quarter circle, and then this half of the rectangle here is unshaded, so that's how we get this equation. I'm pretty sure I explain it right here. So we divide the area of the circle by 4 because the shaded portion is contained within a quarter of the circle. And then we divide the area of the rectangle by 2 because half the rectangle within the shaded portion is unshaded. And then what did I write right here? So find the area of the circle by using the following equation, pi r squared. We know that r is equal to 8.500. And then we find the area of the rectangle by multiplying width times length, but we need to figure out what width and what the length is right now. So now for the math. Oh, this is why I don't have the 8.500 up here. I didn't do any of the math up here. I was just using, or I was making a list of steps to follow. So now for the math. So first of all, we need to find either a length, the exact number for length, or the exact number for width in inches. So we have our equation, 1/4 of the perimeter is equal to length plus width, and we put this over here. We have 11.50, which is 1/4 times the perimeter with the correct number of sig figs, minus the width is equal to length. Now we go on to step 2, which is, what are we trying to do here? We're trying to find the radius. So we have 17.00 pi, which is the circumference of the circle, is equal to 2 pi r. Divide that and divide 17 pi by 2 pi, and you get the radius, which is 8.500 inches. Step 3, we're going to be using the Pythagorean theorem now. Here's the radius, 8.500 squared is equal to width squared plus plug in the expression for length, 11.50 minus width squared. And now we get this. I just expanded this out because we're going to need to FOIL this. So 8.500 squared is equal to width squared plus 11.50 minus width times that again. And after FOILing it out, we get 8.500 squared is equal to width squared plus 132.3, which is to the correct number of sig figs, minus 23.00, which is also to the correct number of sig figs, w plus width squared. And then we move this over here, the radius squared, to the other side. So we can get an equation we can put into the quadratic formula. So we get 0 is equal to 2 width squared minus 23.00 width of the smaller rectangle plus radius squared. So now, just checking my math, yep, so we subtracted this from this right here, 11.50 times 11.50. So now we can use the quadratic formula, if I'm remembering that right, to find the width of the small rectangle. So we get, we plug b right here into right here. We plug b right out here. I wrote down, I moved this to right here. So we plug b in for b squared, so negative 23 squared, which is 529, minus 4a, which is 2, because of right there, c, right there, and we get 529.0 minus 480, and since the sig fig rule makes it so there's no decimals, so our answer should have no points beyond the decimal, or numbers beyond the decimal, so we have 49. 529 minus 480 is equal to 49. And then we solved that. I plugged into my calculator, and I got the width of the small rectangle is equal to 7.5 inches or 4.0 inches. And we'll see later on that you can just choose either or, because the length is going to be the other one, whichever one we don't choose. But going on, and just to prove that, we have we go back to our perimeter is equal to the width of the small, or 1/4 of the perimeter of the large rectangle is equal to the width of the small rectangle plus the length of the small rectangle. So we get 11.50 minus 7.5 is equal to the length of the small rectangle, which is equal to 4.0 inches, which we have right up here because we used 7.5 for width. And this makes sense because this equation up here is telling us that width could be either or, and in this equation, same thing. If we plugged 4.0 right in for width, then we get the length is equal to 7.5. In this problem, it doesn't really matter which one is 7.5, which one is 4. It's important to note that they should add up to 11.5 in the end. So right here, I'm finding the area of the circle, and that is just the pi r squared. Radius is 8.500. So we get the area of the circle, keeping the pi in there because that's what the problem asks for, is 72.25 inches squared times pi. The area of the rectangle, which is width times length, is equal to 30 inches squared because 2 sig figs times 2 sig figs will yield 2 sig figs. And now we're going to jump back up here to our equation of 1/4 area of the circle minus 1/2 area of the rectangle to yield the area of the shaded portion. So we have 1/4 area of the circle, which is 72.25 pi inches squared, minus the area of the rectangle divided by 2. In the equation up there, it was 1/2 times the area of the rectangle, but I just did the rectangle divided by 2, which is the same thing. And we get 18.06 pi minus 15 inches squared. So the area of the shaded portion within the circle is 18.06 pi minus 15 inches squared. Or if you multiply the pi if you multiply 18.06 by pi and subtract 15, keeping the correct number of sig figs, there's no decimals after the 15, or no numbers beyond the decimal point. So we get around 42 inches squared. And now we will go on to finding the perimeter of the shaded portion, which now that we have some more dimensions, namely the width of the small rectangle and the length of the small rectangle, it should be relatively simpler compared to finding the area. So here are the steps. The perimeter of the shaded portion is composed of 1/4 of the circle's circumference, which is right here. So there's an entire circle. The crosshair separates it into 4 chunks, and so this would be 1/4 of the circle's circumference, and that's one side of the perimeter we are trying to find. In total there's 4, 1, 2, 3, and I'm considering this a side, even though it has like a curve to it. And once you find the circumference divided by 4, there are 3 more sides to the shaded portion's perimeter. The innermost edge of the portion's perimeter is the diagonal of the small triangle, which we know to be equal to the radius. So this is what I'm talking about right here. There's 2 diagonals in this rectangle, one right here, one right here. They should be equal. So if this one is the radius, because it goes from the center to the perimeter of the circle, then this should also be equal to the radius. And the other 2 sides of the portion's perimeter are equal to the difference between the radius of the circle and the side length of the rectangle. So for example, if we want to find this right here, we know that from here to here is a radius centered to the perimeter of the circle. And we want to find this right here, and we know that this from center to right here is the width of the small rectangle. So if we subtract this width from the radius, we will get this part left over, which is another side of our shaded portion. And then we'll do the same thing for this side right here. This is the radius. Here's the length of the small rectangle. And if we subtract this length from the radius, we'll get a yielded answer of right here. So I'm explaining this right here. One side will be radius minus the width of the small rectangle, and the other will be the radius minus the length of the small rectangle. We can now find, so now that we know, now that we have these equations, we can now set up an overall equation to find the perimeter of the shaded portion. So we have 1/4 of the circumference right here, plus the radius right there, plus the radius minus the width of the small rectangle, which is right here, and radius minus length right there. So now for the math. We have 1/4 times the circumference, which is 17.00 pi, plus the radius of the circle, which is 8.500, and then we subtract the width, which we found earlier, from the radius, the width of the small rectangle, and then we do the same thing, but with the length of the small rectangle instead of the width. And after solving that, we get 4.250 pi plus 8.500 plus 1.0 plus 4.5. We should get an answer with one significant figure. Or in this case, the perimeter of the shaded portion in terms of pi is 4.250 pi plus 14.0 inches, which is approximately, if we plug in 3.142 for pi, is 27.4 inches. And that is the 75-point part of a circle problem solved. Next, I chose to do the 25 points problem, budgeting your time. So for this problem, you're a conscientious student who wants to get everything important completed in your day before watching TV, playing video games, etc. Your day consists of the following. 1/8 of your day is spent learning in school, another 5/16 you earn money at work. To pass your classes, 1/15 is spent studying. You rush through your meals, so only 1/32 is used up eating. 18 minutes is spent making yourself presentable for the day, and you get 6 hours of sleep every night. Lastly, you do live close to work and school, so only 1/30 of your day is spent commuting. If you go to bed every day at midnight, what time will you be able to begin your fun and unwind for the day? All right, let's find out. So I made this little picture right here, a little kind of chart, like 1/8 of your day. This is one day. This rectangle right here, 1/8 is spent learning. This is not to scale. This is just something for me to like look at, and so I know what I'm trying to find. So 1/8 of your day is spent learning, 5/16 of the day is spent at work, 1/15 studying, 1/32 eating, 18 minutes for preparation, 360 minutes, which is equivalent to 6 hours, is spent sleeping, 1/30 of the day is spent commuting, and then we're trying to find how much of the day, how much at the end of the day is left for fun. So find what time will fun begin for the day, or what time will unwind, etc. What we know, so I put down everything we know. 1/32 of the day is spent eating, and so on. Same things up here. And then also we go to bed at midnight. So the fun will begin after. So we have midnight, and then we actually I think I have it in my assumption right here. So every other task is finished before fun begins. So starting at midnight, every other task is finished, and then fun begins, and then midnight. And then sleep, tasks, fun, midnight, and then we continue on and on. An estimation, fun time will begin late in the afternoon because you're adding up all these tasks. So, and then there's like, there's 6 hours here, there's going to be a bunch more hours here, so my guess is that fun time will begin later in the afternoon. Variables that we will be using, we're only going to be using like 2 main variables for this problem. TF, which is the total time to complete tasks that were given a fractional value, so like 1/8 of the day spent learning, 1/32 eating. I'm going to add all these fractional values up, disregarding these that were not given a fractional value, and we'll add those on later in the problem, and that's where this part comes in. So TM is the total time to complete tasks whose time in minutes to complete were given. So these ones were given like a specific time. They weren't given a fraction of the day. So we'll be adding those up separately. And here are the steps. So we want to find the combined time of all of the important tasks so that we can find out how much time we have left to unwind for the day. First, we need to find a common denominator for the important task fractions. So to add all these up, we're going to need to find a common denominator so that we can commence the addition. So once all fractions are converted to have the same common denominator, once again I'll do the math down here. So I'm just listing out the steps. So once all fractions are converted to have the same common denominator, we can add them together. And then next we can multiply this fraction by the number of minutes in a day to see how much time these tasks are taking up. Step number 5, we can then add the tasks whose times are already given in minutes to the amount of time needed to complete the tasks whose completion times were given in fractions. So that's why I'm separating them, because first we're going to convert these fractional times to minutes, and then we'll add those to the already given times that were already given in minutes/hours. And then step 5, already went over that one. Step 6, finally, we're going to convert the total time it takes to complete all the tasks to hours, and we're going to find how many hours after midnight that you will be able to begin your fun and unwind for the day. Alright, so the math. Here's the overall equation that we're going to be using for the fractional, for the tasks that were given a fractional amount. So right here we have 1/8 plus 5/16, so 1/8 of the day is spent learning, so that's why that is there. 5/16 of the day is spent at work, and so on. We just have all the fractions, 1/8 plus 5/16, and so on, and then we multiply that by the minutes in a day to find how many minutes that those tasks are taking up. And then to find the common denominator, we know that 8 right here and 16 go into 32, and 15 goes into 30. So we just need to, well, obviously 30 does not come to 32 and vice versa. So in theory, if we multiply 30 times 32, these two numbers multiplied together will yield a common denominator for each and every one of these fractions. So once we multiply, we get the common denominator is 960, which it doesn't really matter if it's the lowest we can get or whatever. So over here I just convert minutes in a day, or I convert 24 hours to minutes in a day, so we have 1,440 minutes in a day. We'll be using that later on. Back over here to converting the fractions. So we have 1/8, which is the time spent eating or something like that, is equal to x over 960. So we have to convert this to another fraction where 960 is the denominator, so we need to find the numerator for this. So we just use algebra, and we multiply 960 over here, multiply x by 8, divide 8 on both sides to cancel out the 8 over here, and we get that x is equal to 960 over 8, so x is equal to 120, so we put it back over here, and we have 1/8 is equal to 120 over 960, and we're just going to continue to do this with all the fractions that we put into this formula. And now, so once we convert all those to this, we can plug them back into the equation for TF, which is total time to complete tasks that were given a fractional value. So we get, we add those all up. We multiply 1,440 by that fraction, and we get 819 minutes on the dot. And then right here we have the time, or the time it takes to complete the tasks that were already given, or that the minute/hour times were already given. So we have sleeping right here, which is 360 minutes. And then we have preparation, which is 18 minutes, so we get 378 minutes. We multiply these two together. This is basically multiplying all the tasks together now that we have all their time in minutes. And we get it takes 1,197 minutes, or 19.95 hours, to complete all these tasks. To get 19.95 hours, you multiply the minutes so you multiply 1,197 times 1 hour on top over 60 minutes. I could have written that down, but it's pretty straightforward. So down here, step 8, we take the number of hours in a day, which is 24. We subtract the 19.95 hours that it takes to complete the tasks, and we get that you have 4.05 hours to unwind and have fun. Just this 0.05 here, the question asks, if I can find it, or I don't know, but we're asked to find the exact time down to the minute. So this 0.05, we convert that here using 60 minutes over an hour is 3 minutes. So we go to midnight, and we find what time does fun time begin, all the way up to midnight, because midnight's when you go to bed. The time before midnight is when you're having your fun, so you subtract 4 hours here, and you get fun time begins at 8 p.m. But then you're like, oh wait, I need to factor in the minutes, which is 3 minutes. So you subtract 3 more minutes from 8 p.m., and you get that fun time begins at 7:57 p.m. And right down here I put 7:57 p.m. is the time that you'll be able to unwind and be able to begin your fun for the day. And that is that problem. I'll wrap it up.